So basically, guys, this is a engineering drawing basics webinar. It is going to take maximum 60 minutes. And in this complete 60-minute, I'm going to explain you the basics of engineering drawing, like what are all the components and what are all the details that we should include into engineering drawings. Like if you are from mechanical industry or architectural or civil industry, you know the importance of technical drawings, right? So we had to learn how we can create accurate technical drawings, accurate engineering drawings that will help manufacturing person, people, or the organizations to prepare or uh, manufacture the parts accurately. So in this complete workshop, we'll talk about all the aspects of engineering drawings. What are all the important components? What are all the details? How to consider those details and why it is important. And all the time, if you have any questions related to it, you can ask me in the chat box. And for this complete webinar, complete workshop, we are going to use a software called Autodesk Fusion 360. So if you are following me, I used to create so many contents related to Autodesk Fusion 360. And if you will join my platform, you will get access to all my free courses, webinars, and seminars. So right now that you can see on your screen, it's about all about engineering drawing basics. So I can see few people has already joined, like Cadron 3D. Thank you so much for joining, coming to this workshop webinar. Praise Tom, he's from Autodesk. We had just talked about lots of stuff related to Fusion 360. Then we had Sravan Kumar, Santanu. Thank you so much for joining, guys. So without wasting much time, since we are already on time, we had scheduled this workshop webinar from 15 IST, 15 p.m. IST, and it's the time is already 15 p.m. right now. So we'll just proceed with our schedule. And all the time, I'm again repeating, if you have any questions or doubt, you can just comment in the chat box. You can ask me in the chat box. I will try to answer them. Now let's move on to the agenda for the today's workshop or the webinar. As you can see, these are all the topics that we're going to discuss today. The first thing that we'll learn about the purpose of engineering drawing, why we used to create engineering drawings. So we'll learn about that. Then we'll also learn about the structure of engineering drawings, like what are all the important components, elements that we should include or remove from the while preparing our final engineering drawings. Then we'll also learn about the drawing views, like what are all different views we can consider into our sheets that we are preparing, the drawings that we are preparing. We'll also talk about the line types, because line types are really very important. It just enhance the quality of your engineering drawing if you consider the right set of line types. Then we'll learn about the dimensions, and the dimensions are one of the most important thing in any of the drawing. If you will not consider the right set of dimensioning methods, your drawing will not going looks good. Also, it will not be accurate. So selecting the dimensions, selecting the dimension types is also very important. And then we'll talk about the drawing notes, like what are all the notes you should include into your drawing and what is the best place for it. Then we'll talk about some of the clarity factor, like what are all the information, whatever the information that we are including into our engineering drawings, it should be properly arranged, like for the clarity. So if someone is reading those drawings, it must be very much readable. And in the last, we'll have a small Q&A session. So if you've got any suggestions, questions, you can just ask me. You can, if you want to give me any suggestion, you can just tell me. If you want to share something, just let me know. So these are the basic things that we're going to discuss in this today's webinar. Now let's move on to our first thing, purpose of engineering drawing. Why do we create engineering drawings? So I had categorized all these three purpose into three different categories, as you can see. The first thing is, guys, the communication. We create engineering drawing to communicate, right? We want our engineering design department to communicate with manufacturing design department, because those people who are into design departments, into any companies, they had access to the CAD software. They do have access to different tools where they can look models from different angles, but the person who was working in the workshops, who are onto the manufacturing floor, they don't have access to those tools, or they don't have time to uh, go and check onto the computer or PC. So what they usually do, they used to take printout of the drawings. They need flat drawings where all the details are clearly mentioned, and for that purpose, to communicate between both the departments, we used to create engineering drawing. That is one of the purpose of creating engineering drawing. The second thing is for the quality inspection purpose. If you had manufactured your part or model, to inspect that model or thing, you need a sheet where you can like you can check out take out some of the quality test it has passed, like you can verify the dimensions, tolerances, and the stuffs like that, if all the features are there on your part or not. So for the quality inspector inspection purpose also, engineering drawing is as is one of the essential thing. Next thing is the contract. So it also work as a contract document. Like if you are from design department and if you had created a technical drawing, so when it goes to the manufacturing department, they will consider that document as a contract document. Like they will consider that document as a final document, and accordingly they will start preparing, they will start manufacturing the parts. If you had given some wrong information into your drawing, the parts will get manufactured wrong. So that's the one of things. So that if it's the complete responsibility for the designer or the CAD engineer or the mechanical engineer. So to make sure that whatever the drawings you are creating, whatever the information you are including into your drawing, that must be accurate and well organized. Also, it is clearly communicating with your stakeholders like the manufacturing people. So these are all the things you had to consider. We'll also dive into the Fusion 360 and we'll show you like how we can start creating engineering drawing. But since we are talking about the purpose of engineering drawing, these three are the purpose I would recommend. Otherwise, if you know something else, you can just comment in the chat box apart from these three things. So let's move on to our next sheet. Let's move on. Let's talk about in detail every points, like what is the structure of engineering drawings. So as you can see, we have talked about the purpose of engineering drawing. Let's move on to the structure. So before going into the deep into the structure of engineering drawings, we'll move into the Fusion 360 and we'll try to create a small technical drawing for this particular model. So let's start creating drawing from this model. So this is one of the model I had created in Fusion 360. It is not being created in Fusion 360, but is being imported into Fusion 360 as a step file, as you can see, and that we can verify because we don't have any design history active at the bottom. Also, if you expand the bodies folder, you will be able to see only single body. So this is the model that we had in our Fusion 360. Now we'll start creating drawing, and that we can do simply by going the area over here that you can see that says file. Just click on this small drop down, and from there is an option called new drawing. So we'll click on that, and it goes from here, new drawing from design. So we had the drawing a design active at this moment, and now we want to create a drawing from this design. So I will click on this from design, and then it will just open a new panel where I had to include few more information, like whether you want drawing for the complete assembly. So yes, for the complete assembly, and the size I am selecting for the seat is A3, and the metric system that I am following, the unit system that I am following is millimeter, and the standard is ISO. So these are the things you can customize accordingly. Like if your company is following some certain amount of standard, you can go with that. But in our case, we are going to take the ISO, and the units that we are considering is millimeter. And most of the cases when you are preparing engineering drawing for the workshop, mostly in case of small parts, the A3 paper size is enough. Otherwise, if you are preparing architectural, civil, or the drawings like that, or structural drawings, in that case, you will need bigger paper size like A2 or A1 or A0 paper sizes. But in case of manufacturing drawings for precise parts, A3 paper size is enough all the time. So I will select A3 over here and will press OK. The moment I will press OK, it will take few seconds to open my drawing space to create my technical drawing. And automatically it is assigning me, here you can see it is assigning me the box and then the drawing views as well. So I will just press escape on my keyboard. I don't want to take any views at this moment. So I just want to explain you the structure of our engineering drawing. Like the first thing is, guys, the drawing border that has always to be into your drawing sheet. And this is the drawing border. This drawing border is basically given, this drawing border is designed based on your seat sizes. If you will change the seat size accordingly, the drawing border size will also change. In this case, this border is being created for the A3 paper size, and all the time you had to include this design border. This is one of the important component of Fusion 360, because you can see, when you will see carefully to this design border, it is also divided into grids. You can see that 1, 2, 3, 4, and on the other side it says A, B, C, D. So what happens, like whenever you are communicating this drawing with someone else, let's say you want to talk about this corner part, right, right top corner part. So you can directly indicate someone, like I am talking about the A7 area. So it will be A grid, and this side it will be the seventh grade. So that you can directly communicate with your stakeholder that just look at the A7 grid area. I'm talking about that particular feature or section. So it will be easy to communicate if you are taking a drawing having multiple views and the stuffs like that. So that way, this grid helps in our engineering drawing. Apart from that, the next thing that we must include is the revision table. So right now we don't have any revision table active at this moment into this drawing, but we should always include that. Like, so we'll just go on to the table and we'll try to put some table like this. So this table can be used for anything. You can use this for revision table, you can use this for bill of material, you can use this for some other information, but revision table will always be there. And most of the time revision tables will keep at the bottom left, right? So the benefit of having a revision table is that, okay, so someone is asking something. I can see someone has raised hand. Sanjeet, do you have any question? If you have any question, just write in the chat box. Anyway, so you can see this table. This, let's say this is a revision table. So how revision table helps? Let's say you had created this drawing, right? And you had included few features dimension, and you had sent it to for the approval to your manager or anyone that who is senior to you. So if someone is commenting onto that drawing, you can just include their name, date, and you can take their sign as well. So if whatever the changes you had made to the drawing, someone has already reviewed it, and accordingly you can include those information in the revision table. So that's the importance of having revision table inside your drawing. You will have complete track record of all the changes you are doing, all the feedbacks you are taking from the clients. So that all will get recorded into the revision table, and we'll have a full control of the design iterations as well. Like whatever the documents we are updating, we can include those information as well. The next thing that comes is the title block, and title block is really very important. So as you can see on this right bottom corner, this is called title block. So any drawing that will not have any title block, it's impossible to know like which company has created this drawing, who are the person involved in creating this drawing. So those are the stuff you had to take care of. So someone is saying that I'm not able to access chat box, no mic option is available. uh I'm not sure like what kind of view you are getting on your end, but anyway, if you had any questions, you can also communicate with me on the community tab onto the webinar page. I can answer from there as well. Otherwise, if you are into my, yes, you can use Q&A section of the panel, Sanjay. Okay, so then we are talking about the title block, right? So the title block includes all the information about the person who has created this drawing, who has approved this drawing, what is the drawing number, and all those stuff. So we'll talk about like what are all the important aspects of a title block. So let's see. Right now that you can see, the first thing that always be there is the title of your drawing. What is this model is about? Let's say we were trying to create drawing for this particular model, and let's say we are calling it as a plastic part, right? So we always had to include and write over here inside the title block. Just double click on the title block and you can rename it and write plastic part, something like this. and we'll click on the finish properties, and you can, okay, let me just press enter. Plastic part. Here you can see, and we'll click on the finish properties, and this is the title of our drawing title, we can call it. So this is one of the most important thing. This directly communicates with our other stakeholder that this drawing is all about the plastic part, and this is the written in the one of the bigger text inside your complete drawing. So if someone is taking your drawing into their hand, the first thing they will be able to say is the title of your drawing. So that is the most important thing and has to be communicated very clearly, whatever the part name is. The next thing is the drawing number or the part number. So the drawing number and part number is also very important. In some cases, what happens if you are associated with any company or any organization, they had some serial number of their parts. So you had to accordingly give number to your parts. But if you are a random person or a hobbyist person, you can give any part number of your drawing, so that it will be easy to for you to track your drawings, right? You track your parts. If you are working with a bigger assembly, let's say it has more than 100 parts, so if you'll just rename your drawing number or part number in a correct manner, so it will be easy to track for you. So that this drawing number area is also very important. And I told you most of the companies has certain rules to create drawing numbers. Like some companies are using some uh, uh, product management softwares to derive these drawing numbers. So from there you can take their drawing numbers and accordingly you have to use into your drawings, right? So drawing number is also very important. The next important stuff is the company information, like which company has created this drawing. So the company information you can include it over here, but it's not necessary that the company information will always go over here. You can include somewhere other space as well, but it's completely your choice, but has to be onto the title block, right? It has to be onto the title block because that will give an idea about the brand reputation. Let's say a company, let's say Fusion 360 is the company who is preparing this drawing. So the Fusion 360 has to include complete information like what is Fusion 360, their logo, their little bit of address, so the stuffs like that. So the company information is also really important when you are creating technical drawings, and that information has to always be in the title block. Okay, so I am seeing a question like Chandra Kiran is asking, hi Prashant, in case of sheet metal parts, do we include the flat pattern of the part in the same drawing as the part drawing? I'm not sure how other companies follow, but I do it one single drawing sheet. Is that no? It's not a correct way, Chandra Kiran. I always recommend to prepare flat patterns on a separate drawing. The reason I say is like the reason to create flat pattern is like whenever you will send the flat pattern to someone else, they will take that as a DXF file and will try to do that, use that means information for the laser cutting. So it's really very important that whatever the flat patterns we are creating, that will have a separate sheet, whereas the layout for the sheet metal parts we have to create in a separate sheet. Complete layout details like what is the overall size, what are all the features and the stuffs like that. Whereas the flat patterns will go onto the separate sheet with little or very less dimensions in case of sheet metal. So this is how I follow for the companies I had worked so far. And it's completely your choice, Chandrakaran, but I always suggest to prepare flat patterns on a separate drawing. Okay, I hope my answer has helped you. Next thing is we had talked about the company information. Next thing is the part information that I always go down to the drawing. And when we talk about the part information, it includes information like the material of the part, estimated weight of the part. So we always had to include those details. But in this title block, you can see that we don't have any space for the material and the weight of the part. So how we can include that? Then we had to customize this title block, and that we can do. We'll expand this option from over here, sheet settings, and you can see this option that says title block. So this is the title block that is active into our drawing right now. So what I will do, I will click on this small pencil icon that you can see over here, and we'll click on that. And here you can see this is my title block, right? So to edit that, okay, so to edit that, what I had to do, I will make a right click onto this. I will click on the edit title block, and here you can see it's selected. I will press OK, and now we are into edit mode. Now we can include few more columns into our title block. So I will activate the line tool. I will create a line like this. So I had separated this space into again into uh, two different sections, as you can see. And here I will include a text called, let's say, weight. I want to include weight of this part into this drawing. So I will write weight. I will press close. Then again, what I will do, I will go on to the text section. I will activate the attribute tab. I will place it over here. And inside attribute, I will make sure that I am selecting the weight of my part. And I will press close, finish title block. Here you can see. Since we had not included any view into this drawing until now, that's why it says the weight is just coming as the random numbers. The moment I will include the part into my drawing, this part, and if you will just make a right click and we'll see the properties of this part. So let me just check. We'll right click. Okay, so here is the property panel just got open. So here you can see the weight says 816 gram, right? Less than 1 kg. And it's all because of the density that we had considered. So we'll change the material, the part weight will accordingly update. But let's consider this is the weight of this part. So the moment I will bring the part into this space, automatically this weight will update. So this is the one of the information always has to be there into any of your technical drawings. The next thing that is come is like finish information. So most of the time we used to write some notes like if there is any surface finish limits that we had to specify, we can do that, but it's not necessary. The important thing are like weight and material that has always to be there. And here I'm not including the material at this moment because we are also going to include the bill of material, and there I'm going to include the material option. So you don't have to repeat information in your complete drawing. Make sure that at least at one place a certain information is available. But in title block, these are the things that I had talked about: the drawing title, drawing number, the revision date, then the company information, weight, and material. This is where the basic information that has always to be there inside your technical drawings title block. Now let's move on to other things like there are few more stuff like you had to specify the system of units that you are following, like whether you are following feet, millimeter, or inches. That always has to be there. Here we don't have such information, but has to be there. Then we got some drawing standards. Let's say if you are following ISO or ASME or some other standard, you had to specify those information as well. But those information we can also include in the drawing notes, right? At drawing notes. So these were the basic things about the drawing title block. Now the next thing that we had to talk about is like we had learned about the title block, we had learned about the revision table and the drawing border. Now let's move on to the next topic, that is the drawing views. Now here we'll learn how we can include different drawing views into our drawing. So before that, I will just delete this table. So how we can bring drawing views like this. This was the model that we had created. Now we want to take a different views of this drawing, right? So when we talk about the views, there are three kind of views we generally take into our drawings. Four kind of views, sorry. The first is the basic view, like the top view, bottom view, side view. These are all called basic views. Then the section views, like if you want to see a section at a particular plane, you can do that. You can take that. That is called section views. And we'll learn how we can create these views inside Fusion 360. Then we'll also talk about auxiliary views. Like if you want to take views along a particular plane that is inclined at a certain angle. So that we can also consider into our drawing. That is called auxiliary views. Then detailed views, like if there is very intricate features that we cannot see into our printed drawing, then what we do, we used to take detailed view of that particular area, we scale it up and we'll put onto our drawing set. So that helps in considering the different drawing views of our drawing. So here you can see. So now what I will do, I will click on this base view. Here you can see the option inside Fusion 360 inside the drawing panel. It's a base view. So the moment I will click on that, here you can see I'm getting the first thing that I will take is I will take the top view. So I had changed the top option over here on the orientation panel, and by default the scale is 1:2. So that we can change. Let's say if it's looking something like the view that we are taking is very small, so we can change the scale. We can change that to 1:1, something like this. And here you can see it just got updated. I will click on the area over here, and it has just created this view. And also in the style style is like a visual style. So that right now you can see it's a kind of stated style. But here we had selected this option called visible and hidden edges. And the moment I will press OK, this style will get applied. See, right? So this is the basic style we usually take for all our design and drawings. This one, visible and hidden edges. So it'll make sure that all the visible and hidden edges are visible onto your drawing, so it will be easy for us or the manufacturing people to read your drawing. So this is one of the view that we had created, and this was the top view. Now using this top view as a parent view, we are going to create two different views, that is the side view and the front view. So for that we are going to use a tool called projected view that you can see over here inside the drawing panel. I will just activate this tool. Then I will just select my base view or the parent view and will drag it like this, and it will automatically create the other view. Like let's say if this is the top view, then this is definitely the side view, right? And if you'll drag towards bottom, this will be the bottom view. And we'll click on this icon over here. It will accept and create three different views. So for this particular design, we had created three different views. Top view, this is the top view that we can see. If we'll double click on the view, it will show me the option, and we'll double click on this one. It says it has been derived from parent view. So this view has been derived from parent view. And again, this one is also derived from parent view, right? So if I will select this one, and if we'll edit this one as a, instead of top as a bottom view, so accordingly the other two views will update. You can see that. So since this is the parent one and the other two views are connected with this one, so if I am updating the basic one, the parent one, the child ones will automatically update. I will close it. So here are the three views that we had created, and all these three views are called basic views that we had just talked about into our drawing view. Now let's learn how we can create section view. So let's say there are some information into your drawing that is not visible into these three views. So to show those information, we had always an option called section view inside Fusion 360 or in any of the CAD software. The things that I am talking about right now is applied to all the CAD software, whether you are using SolidWorks, where you are using Fusion 360, Autodesk Inventor, AutoCAD 3D, all the tool. If you are creating technical drawing, these are the basic stuff. These are the basic information that you always need to know. And again, guys, if you have any question, just comment in the chat box. I am here to answer all your questions. Also, you can write yes. If you can see the question and answer section, just write your question over there. I will help you in that. Also, when this webinar or workshop will end, you will be able to find the recordings as well. Like if you want to go with detail into the certain area, you can watch the recording that will be available onto our dashboard, also into our YouTube channel. So as you can see right now, we had learned about the basic views. Now let's move on to the section views. To create section view, there is a tool called section view. Here you can see inside Fusion 360. So if I will activate this tool, now section views are basically created based on the planes. So first it is asking me to select the parent view on which you want to create your section view. So let's say I want to create a section view onto this view or this view. So I will just select that. Here you can see the moment I had clicked on that, a new panel just got appear over here, and it is ready to create section view, right? So now I will just click on any of the point. Let's say I want to create section along this line. So I will just click on this point and then the other point on the other side, and then I will click on this finish icon, and here you can see it is creating a section view. Now the section view has been created. So if you want to create a section view from this direction, you can do that. If you want to create a section view from this direction, you can do that. So accordingly, when you will move your views, the section lines you can see is getting updated, right? So let's say I want to create a section views on this direction, but since it is connected with this part, I'm only able to move my views horizontally along this part. Now to move it freely, we had to use a tool called shift one time. Just press shift key on your keyboard one time, and then you will be able to move it freely anywhere across your design or drawing space. Now if you would like to put it over here, I can do that. And when I am done with that, here you can see there we got few more options like the section view that you had created, whether you want that to be like tangent is visible or not, or the stuffs like that. So you can control those things. Also, whether you want to be like visible and hidden edges or visible edges. So I will select this one, visible and hidden edges. And then the depth, I want it to be full, and we'll press OK. So there are multiple things that you has to learn, like what is the depth of the section and the stuffs like that. Those stuffs you will master once you will start creating more and more technical drawings. You will understand all those technical terms, like what is the meaning of depth of section and the stuffs like that. But the basic section that we can create, I had just shown you. Like if you will just cut your part through this line towards this direction, and if you will see from this direction, you will be able to see part like this. This is the section view of this part along this plane. If I will just draw a line, vertical line like this, and will cut this part uh, from this view, we'll get a shape like this. So this is the part. And all the solid lines that you can see, solid hatches, it says solid wall. So there are some solid walls. And these hatches show that there are some solid walls, something like that. So this is the section view we had created. Now the annotation for the section view is this a section, and that is in 1:1 scale. But here you can see we are getting some problem in adjusting this view and placing it. So we'll just little bit move the stuff little bit. So accordingly we'll little bit adjust the stuff. So all the time you can just drag your parts and the views little bit upwards and downwards just to adjust into your drawing sets. So everything is more readable and also easy to communicate with your stakeholders. So here you can see, this is the section view that we had created inside Fusion 360. Now, the thing that we were talking about was we had learned about how we had created top view and side view or the front view. So all the views we can create using the parent view, also using the default views. So we had learned about creating top views, front view, side view. Now, whenever you are creating drawing, there is one more view that is also very important, that is called isometric view. So why isometric view is important? Because that will give an estimate idea of your manufacturing person, like how your part is going to look at the end. So that is also very important, and that we can also do using this same tool called project tool. We'll activate this tool, we'll select the part, and instead of dragging towards this direction or bottom, we'll drag towards 45-degree angle, and you can see the part view that is we can see. So since this isometric view is not correct, so we'll try to see it on a different angles, and we'll see which one is coming good. So none of them is coming good. So what we'll do, again, we'll activate the tool, we'll select other parts, and we'll see in which direction we are getting the correct view. Yes, this is the view that we are getting correct, and we'll press OK. So this is the view that we are getting correct. So we'll just double click on it, and in isometric view, I always want to keep it on a shaded view, shaded kind of visual style, not like a wireframe. So it will be easy for me to understand or the workshop people to understand. So you can see I created that. I will press OK. And I don't want this to be big this much enough, because this is just to give you an idea. So I will just double click on it. I will change the scale for this particular view only. So I will change it to 1:2, little bit smaller, and we'll close it. Now I can just keep it anywhere onto my drawing space if I had some space to keep it. Let me find some space just by dragging the parts here and there, because I had to include all the information, right? So here you can see, I had just placed one of the isometric view into our drawing, and this is how now it looks like. So we had included few things like top view, bottom view, side view, section view, and isometric view. So these are the stuffs that we had included into our drawing. Now the next thing is auxiliary view. So I told you the auxiliary view is like creating section at a particular angle. For example, let's say here you can see this is the view of our drawing, and now there were some inclined part. In this part there is no inclined part, but let's assume that we had some inclined part, and we want to see it according to that. So if I will just hover over to this option over here, you can see it says auxiliary view. So we'll activate that, and now I can create view at any particular inclined angle. So let's say select this is, so I can create views according to that particular is. Here you can see that. So this view that I am creating, if someone is looking this part from this direction, I mean perpendicular to this plane that is inclined at 45 degree right now. So if someone is seeing this part from this plane perpendicular to this plane, he or she will able to see a part like this. So that will be the view of this part from, if you'll see it from perpendicular to this plane. So this is called auxiliary view. Auxiliary view is like a additional view, you can say that, but this is not a standard. In some cases, let's say we had some hole onto this inclined face, then just to give the dimension for that particular hole, we had to show a auxiliary view, right? And there we can dimension the hole details. But it's not necessary all the time. If there is a requirement into your drawing, you had to consider that, because otherwise you will miss some information, you will miss some dimensions, some details, and that is not a good practice, right? Because when your drawing is final and it is getting manufactured in the workshop, and if the parts are not fitting together, or if your parts is missing certain information, certain features, then there will be lots of material loss, there will be lots of manpower loss and resource loss. So the whole responsibility is going to come on to you. So it's really very important you create accurate drawings from your end, and it get approved from your managers, seniors, then it get into the workshop ready for manufacturing. So it's really very important. So I will delete this auxiliary view at this moment right now. So this is how I just told you, like using this tool, you can select any plane at any angle, and onto that plane, you can create your auxiliary views. Now, the next thing is the detail view. So detail view, I already also told you, it's really very important. Let's say here you can see this hole is bigger. Let's say this hole was very smaller. So how we can create a view of this hole? So for that, we got a tool called detail view. Just activate this tool. Then select your parent view first. So I had selected the parent view, and the moment I had selected the parent view, a new window just popped up, a new panel just popped up, and it says specify the center of your detail view. So here you can see, I will specify the center of the detail view and which area that you want to cover into your detail view. So this circle specify the area that you want to cover inside your detail view. So I had just specified the boundary, the area. I will click, and then I can place this detail view anywhere onto my drawing. Let's say I want to place it over here. So I will place it, and the scale for this particular view is 2:1, whereas the scale for my complete drawing was 1:1. Here you can, it's not written into our title block, but it has to be there. And then for the isometric view, we had used the scale of 1:2. So we got 3 different scale onto each drawing. And the moment I will press OK, here you can see, since for this detail view, we were using different scale. That's why the scale is specifically mentioned over here. And for the same for the section view, you can see that. And for 3 different views, we had used the default scale. That was, if you'll just double click on it, you will be able to see it. The scale says 1:1, and that has to be mentioned in the title block. It's not there at this moment into this drawing, and it's not a right practice. We had to include that information all the time, the scale of your drawing into your title block. Otherwise, if someone is manufacturing the part and taking your drawing and will try to relate with that, it will not come accurately. So it's really very important you mention right scale into each into your drawing sheet. So drawing sheet will specify all the views that is not mentioned with any particular scale, and wherever you had changed the scale, you had to specify additionally. So this way you can do that. You can create drawing views, different drawing views across your drawing. So let me know if you got any questions at this point. So we had just covered the different drawing views. Now let's move on to our next topic that is also very important, line types. Right. So the first 3 is the continuous solid lines. So whatever the things that you are creating, the outer shape of your body is all solid line types. So this line type all the time will be default. So you don't have to worry about that. In any tool, in SolidWorks, Fusion 360, AutoCAD, Inventor, in UZNX, whatever tool you are using, solid line types will be default for the outer shape of your body. Then the next line type is the hidden lines. So all the features that are behind the view, like if you are seeing this part from this side, and let's say this whole feature is whether inside your part or behind the part, that will be visible as a dash line. So whenever you will see dash line, this means that this feature is behind your part or inside your part that you cannot see from the front, right? There you can see. That's why they are all dashed line. So wherever you are seeing dashed line, just consider that those are all hidden features. Next line type is center line. So center line, we had not created any center line at this moment, but to create center line, let's say we had this hole over here, right? If you'll see the view onto this direction, let's say we had this hole over here. You can see that this is the hole that you can see over here. So we had to specify the position of this hole. We had to create center line, right? And that we can create using this tool inside the geometry panel over here. If you'll just see the ribbon of your Fusion 360 tool, inside this geometry panel, the first tool is called center line. So if you'll activate this line, activate this tool, I just need to specify the two lines in between which I want to create my center line. So I will specify this line and this line, and automatically it will generate a center line. You can see that. We'll do the same for these two as well, right? And we also got a hole at the center, so we'll also select these lines. So we'll get a center line over here as well. And we'll also select these lines. We'll also need a center line over here as well. So at all the places where you need center line, you just need to specify the boundary, like the right side and the left side lines, and in the center it will automatically generate a line, and that is called center line. So to specify the position of this hole with respect to the side of your body, we had to specify the center line. We had to create the center line, and that is not being created by default. You had to specify it, right? You had to create that, and that is also very important feature, center line inside line types while creating engineering drawings. Next is the center mark. This is also very important. So center mark, I hope all of you are aware of this feature, center mark. Just activate this center mark tool, then select your circle. So center mark is for circles only. Center word is related to circle only. So just select your circles and it will automatically create the center mark. Let's say we got 4 different circles over here, holes. So I will select all the 4 holes and it will automatically create center marks. So by using these center marks, we can dimension the position of these holes, right? Or any feature if you have. Let's say we had this feature, we can click on the outer circle and it will automatically create the center line, right? We don't have to create these things manually. We'll just have to specify all the centers that we had. It's not really important in creating center line into the section views. It's only important in create center lines onto the top, bottom, or the side view, right? Here you can see we had created that. And inside section view, it's also not necessary to provide any dimensions. If it is really very important, you can provide any dimensions, but most of the dimensions we used to provide inside the top, side, and bottom views only, or into the detail views. So here also we had to specify the center mark. So we'll activate this tool, we'll select the arc, and it will automatically specify the center mark. So this is how this tool works, center line, center mark tool. So let me know if you have any questions up to this point. It was very easy to understand. Just take your views, activate the tools, select your profiles, arcs, circles, and it will automatically generate the center mark and center lines. Now, in what happens in case of a certain feature, let's say we are talking about the flange. So flange is having different holes at a particular angle, right? Equally spaced. So in that case, if you want to mark a center line, then there is a special tool for that. It called center mark pattern that you can use that. But in this case, the drawing that we are preparing right now, in this drawing, we don't have any certain feature like that. That's why I'm not using this tool. So if you have that feature, you can use this tool. You got this option, right? Let me know, guys, if you can hear me. Just write yes in the Q&A. Just write yes in the Q&A. Okay, that's great. Okay. So let's move on to the next thing. The next feature that we are going to talk about this dimension, and that is the most important thing, because without dimension there is no technical drawing. There is nothing technical drawing or detail. So if you only, it will be easy to read, it will be easy to manufacture when it will have all the necessary dimensions. So the first thing that come into dimensions is called linear dimensions. So if we'll go on to the Fusion 360 and we'll just go on to the dimension tab, there is a different tab for all the dimension tools. So if we'll go into the dimension tab, we'll expand it. We'll able to see a tool called dimensions. So just activate this tool. And let's say I want to dimension this part from this side to this side 140. Automatically it will give me the dimensions, and this dimension is called linear dimension because it is linear. And when we use the word called linear, this means it's either horizontal, vertical, or aligned, but it has to be straight, and that is called linear dimensions. So here you can see the first linear dimension that we had created is of 140 millimeter, definitely. Then the second dimension that we want to create from this center, so we'll just select the circle and then the other circle, and just give me a second. We'll activate the dimension tool again. We'll select the center point and the center point, and we'll create a dimension like this. Maybe you can see these dimensions are not accurate because maybe in our part the things were not accurate, but you can see this small yellow icon because this says that if you just hover over to this icon, it says that this dimension is not associated with the features that you had created. So here you can see if I will hover over to it and will try to click on it, it says reassociate. So I will click on this reassociate, and in this direction, I will reassociate with the center, and on this direction as well. So now it is accurately giving me the dimensions. So from this center to this center, the dimension is 75. So this is how you can create linear dimensions, horizontal linear dimensions, vertical linear dimensions. It's simple. Activate the tool, select the points. Let's say from this line to the bottom line, the dimension is 85. So it's easy. It's very easy. You can create drawings in fraction of seconds, right? And you can see it's if I'll just select this is associated with this corner, so I will just bring it the corner to up to this point. So there will always be a dimension break with the part, so it will be easy for any person to read these drawings. So this is how what we had get. Now let's move on to the next thing that says ordinate dimension. So what happens in case of dimension types? We normally dimension our drawing using the linear dimension, but that is not a good practice. In case of engineering drawing, perfect engineering drawing, high quality engineering drawings, the drawing that is used by the professionals, they usually used to dimension their drawing using ordinate dimension. And the reason because they used to do it using ordinate dimension, it's because they are easy to uh, interpret onto your drawing. It's readable, it looks clean, it looks professional. So I will show you what is the ordinate dimension. So we'll expand the dimension tool, right? You can see this dimension style called ordinate dimension. So if we'll activate that, the first thing is that we had to specify the origin for this part. So let's say this circle and the center of this circle, I'm considering it as the origin. So I will click on that and I will drag it outside like this, and I will create my first ordinate dimension. So if this is 0, then this circle will be 75 definitely. There you can see. And if you try to dimension this line, this will be, so it is all referenced with this center that we had considered, this origin that we had considered. So accordingly, we can dimension all the features, all the dimensions. There you can see that. There you can see that, right? So this is how we can create ordinate dimensions. And moment you are done, just make a right click, click OK. Sorry, OK, and you are done. And you can see all these dimensions are not aligned, right? These are all like some dimensions are more towards right, some dimensions are I mean they are not vertically aligned. So for that, what we can do, we can select it, and we can go into the dimension tool and arrange dimensions, and then what we'll do, we can select the base dimension. So let's select the base dimension. Okay, okay, it has to work like this. Anyway, if it is not aligning, there is not a problem. What we can do, we can also align it manually, but I will recommend there is always a way using which we can align our dimensions. So it will look more professional if we had aligned our dimensions in a proper manner, in a vertically or horizontally oriented manner. In case of SolidWorks, there is a simple tool. Just select your dimensions. Also in SolidWorks, the dimension will automatically snaps according to the alignment. But in case of Fusion 360, I cannot find such features. But anyway, there is, I believe there is a way that by which using we can do that. So this is how you can use ordinate dimensions. This looks little bit different from this linear dimension, as you can see, since all these dimensions are referenced with one of the center points. And the same in the same way, we can also dimension these things using for the vertical centers. Like if we'll specify this one as a 0, then we can specify this point as a 64 or something. Whatever the dimension is, it will automatically snap that. So you can say again this yellow icon, this means that we have to reassociate with the center. Yes. So this is how you can give ordinate dimension to your drawings or the design. Now, the next thing is this reference dimension. So the reference dimension are basically given to the overall dimension of your objects. Let's say you want to give this dimension just for the reference, not for the manufacturer to consider this dimension for manufacturing. So in that case, what we can do, if there is what we can do, we can just parenthesize this dimension inside a small bracket. So we can give a bracket like this, and we can call it close. So you can see this is a reference dimension. Also, what we can do, we can select any dimension, just double click on it, and here is an option called reference dimension. Just activate that. It will automatically take that dimension into parentheses. Here you can see, we'll close it, and here you can see this is how you can create reference dimension. So wherever we had included this small brackets, this means that this dimension are reference dimension, and these dimensions are just for the overall purpose, just for the reading purpose, not for the manufacturing. So you will consider these two dimensions only for the reference. You will not use this dimension for the manufacturing purpose, right? So this is the purpose of reference dimension. So these were the dimension types that is all really very important if you are seeing any drawing, if you are creating any drawing. The next thing is, guys, this drawing notes, and the drawing notes is also very important, as you all of you know. For example, for this particular drawing, like let's say we want to include any particular notes to the bottom of this part, like I want to machine this part, right? This part, the bottom face has to be machined. So for that, what we can do, we can activate this thing called note, right? Here is a tool inside Fusion 360. If we'll just go onto the text panel, and there is a tool called note. Just activate this tool. Now I will select the A's, will drag outside like this, then I will include my note. Like let's say I want to write surface to be machined. So I will press enter. Sorry, not enter, I will just close it, and it will get created. So here you can see I had attached a note onto our part detail that this bottom surface has to be machined, right? So these information, this note has to have a clear intent. Like whatever information you want to communicate with your manufacturing person, write it directly. Don't confuse him. Simply write whatever the information that you want to communicate. Adding extra notes is not going to hamper onto give any hamper onto your drawing. It will only add more value to your drawing, right? Just don't write random anything. Try to write anything that is specific to the point. Like here I had simply written this bottom surface has to be machined, and accordingly the manufacturing person will get an idea. So the note has to be communicated directly inside your drawing. Then let's say I want to add a note over here. So I will activate my simple text tool, and let's write some note over here. Like since we don't have any units specified onto our title block, so we can write all dimensions are in millimeter, right? We can write it like that. So we had simply included a note into our drawing where we had written all dimensions are in millimeter. We had directly communicated with the manufacturing person or the people. We had not tried to confuse him by just consider those unit of system and the stuff like that. We had simply written over here. Then let's say I want to add a new line. I will press enter, and let's write something else. Like let's write material of CONS material of construction is SS304. Something like that. So whatever the information that you want to communicate, you can write directly, and then I will select everything. I will convert that to a bullet points. So these are the 2 points I want to talk about. And then what I will do, I will press enter, will go on to the top, and I will write notes, something like this. I will close it. So here you can see this is the note we had created. So if it is not fitting over here, what I can do, I can press pull it over here onto the empty area or the space. So the things will be not overlapping with each other. It all the contents, all the features, all the dimensions, specifications that we had considered into this drawing are easily readable. So this is our intent. So drawing notes is really very important. For example, let's say for these holes, if you want to dimension in this hole, just activate the node tool. Sorry, this hole and thread tool. Just select your hole and drag outside. Okay, let me just activate the tools, select the hole. Okay, that is not snapping, and the reason is because I will just tell you. And this hole is, I'm not able to dimension it using the automatic hole tool, is because the model that we had created, as you can see, it has been imported from some other CAD tool. And these holes are not specified since we had imported the step file. If it is originally being created into Fusion 360 using the hole tool, then we can directly dimension those into the drawing space. So that is also one of the things that you have to consider all the time. Like whenever you are creating any hole feature or thread feature or any feature onto your drawing or the model, always try to create using these tools only. Don't just create a sketch and subtract those feature onto your body. If you are doing like that, like whenever you are creating drawing from that particular model, you will face this problem that you will not be able to dimension those automatically. You have to specify every hole separately. So for in that case, you can see we had not created using hole tool, so we can specify the whole features like this. Like we can write it like, let's say 5 5 mm, something like that. Or we can include other information like the depth 6 mm, something like that. So this way we can include information for the whole. Then also we had to specify some more information onto the bottom, like 4 numbers. So this way we can dimension the details, right? For this 1, 2, 3, 4 holes we had specified over here. So those holes are 5 mm in diameter and 6 mm in deep, right? Depth. So this is how you can include notes onto your drawing and make sure that you had included all the necessary notes. So you are not missing any of the information, not even a single information you are missing onto your drawing. So it is like that whenever you had finished creating drawing, none of the person from the manufacturing department will come to you and raise hands like you had created a wrong drawing. Create a perfect engineering drawing that will communicate every features, uh, every aspect of your drawing. It's really very important. Now let's move on to the other seat, that is like clarity. Clarity, the first thing that we'll talk about the overlapping dimension line. So it's really very important. I had seen so many people are getting dimensions like this. Let me show you. Like the dimension like 6, we had created something like this. Then they will dimension something from this to this, something like this. So you can see this is not a right way to dimension. You can see the things are overlapping with each other. So that maybe you in the CAD software you can select your dimensions. In the CAD software you can select your dimensions and move it, right? But when you will convert this document as a PDF, it's not possible. If you had created something like this, that the things are overlapping with each other or something like this, so the person who has printed this drawing, they will get confused. They will, it's really hard to read those drawings. If in this area we have multiple dimensions and few of them are overlapping with each other, that will create lots of confusion. So clarity is really very important, that you are not overlapping any of the entities with each other. Also, the next important point in the clarity is the text size and color. So text size and color is also very important. Like this is the sheet that we had considered was A3 size, right? Paper sheet that we had considered was A3. And when we'll try this same paper, same drawing onto the A3 sheet size, that will come onto a corrector scale. And for A3 sheet size, we had considered this much of text size that will be readable. So whenever you will print this drawing, this text will be readable. Now, let's move on to the document settings here onto the browser. Here you can see there is a panel, this drop down that says document settings, and inside document settings, if you'll go on to the font, and we'll click on this option to change fonts, you can see the size that we are using for the text at this moment is medium, right? And the medium text size are 3.5 millimeter. So all the time, whenever you are preparing your drawing for A3 sheet size, you don't have to consider anything smaller than 3.5 text font size, right? Just keep it in your mind at this point. You cannot take any of the text or the sizes less than 3.5 If it is less than 3.5 there will be a human error in reading your drawings. So make sure that everything that you are considering onto your drawing, any text, any dimensions, any feature, any annotations, that has to be either 3.5 or higher than that for A3 size paper. Just keep it in your mind. And by default, Fusion 360 for A3 seat size, by default, they're already providing 3.5 So that's really great and also saving lots of time. But if you want to change that all the time, you can just come onto your document setting, go onto the front area over here, and then you can change these settings. Like if you want to go to smaller, you can do that. The moment you will press OK, all text sizes you can see just got updated, right? They just got a smaller. So the control is all into our hand, but still we had to follow the right practice. We don't have to take anything randomly, right? Also, color is really very important. We don't have to select any color that is, let's say we had created this drawing and we had selected this drawing in a yellow color. And when we'll try to print it on a black and white printer, it will look very kind of less transparency. So it's really very important that you select a solid color for a black and white printing. But if you are want to print it in color, make sure that you had selected the right color as well, because yellow is not a good color. It is just like a reference views. You can, for reference views, you can use that color. So just consider solid color, and for the solid color, black is always the best preference. Now guys, the next thing is don't dimension hidden lines. So in all the views that we had created, you can see we had dimension hidden lines as well over here, but it's not the right way. Don't dimension hidden line inside your drawing. Only dimension the solid lines that you can see onto your different views. But for the hidden lines here, you can see. So some features will be visible onto this view. Some features will be visible onto this view. And if some feature is not visible, we can select create a section view and we can dimension it over here there. So, but don't dimension any of your hidden lines inside your drawing. The next is the combine nodes and dimension. Also, one more thing. Let's say we had created this center line for this hole, right? We had created this center line for this hole. So we can directly communicate with the drawing people. Like instead of writing notes in here and there, we can simply write it over here. Like we can write a simple note over here that this is the center line of body. We can write it simply. So we can directly communicate whatever the information that we want to provide. We can directly communicate and we can select it. Right. We will try to rotate this one. Transform, rotate, something like this. Press OK. Okay, this is correct. So we can write it center line of body. So it directly communicates this node directly communicates that this line is a center line of the body. So that is what I'm trying to say is like combine nodes with dimension. For example, let's say we had this dimension. Let's say we had this dimension for the diameter of the circle, and since all the four circles are of same diameter, right? So we can write typical over here. So just write typical. So this means that all the four diameter of the holes that we had created is typical in size, same in size. So we can directly include the nodes with the dimension itself, right? There is no need to put the nodes and the dimensions here and there separately. You can directly include nodes. Let's say, for example, for this 75 dimension, we want to include some nodes. So we can just double click on the dimension and we can add some nodes like this is whole position, something like that. We can directly include nodes into the dimension itself, right? We don't have to put these nodes somewhere else or with as a text file. We can directly put it inside the dimension, because when we are updating or moving this dimension, it will just move with the node, right? The node, the information that we had provided for this particular feature. So that is what we are trying to do. Combine nodes with the dimension. Choose correct scale. So in the beginning, I told you taking the correct scale is really very important, because otherwise you had to the reason for selecting the correct scale is you want to utilize the complete area of your A3 sheet. You don't want to consider everything very smaller and half of the space of your sheet is empty. You want to completely utilize the space of your paper, and by considering the right scale. That is the purpose. So here you can see our drawing is almost full, right? Someone will print, he will be seeing that my drawing is almost full, and also we had provided all the details. So that is really very important. And the last thing is include isometric view, just to give an idea to the manufacturer. So overall part, how it will look. So it will just give him a confidence with the part that is he is going to start with. So isometric, including isometric view is important. And it's not necessary that you include it in a shaded view. You can also include it in this view, visible edges only. So that will also give you a good idea, but it's also easy to print onto black and white printer, and it will not going to take so much of ink, we can say that. So here you can see that. So these were all the points that we had targeted for this today's webinar or the workshop. Let me know if you got any questions. Just write it in the Q&A section. And if you guys don't know me, guys, I'm Prasant Kumar. I'm a mechanical engineer like you as well. I graduated back in 2009, 2013, sorry. And I do have lots of experience in different industries like chemical, construction, automobile, power sector like power plants. So, and from past few years, I'm working as a full-time freelance CAD designer. I had worked with so many platforms, so many clients. So I'm very much active on platforms like LinkedIn and the platforms like fiber.com, freelancer.com. So you can find me there. I'm also expert in softwares. I will not say expert, but I do have good knowledge in softwares like AutoCAD, SolidWorks, Fusion 360. So if you have any questions related to any of these softwares or the topics, you can reach out to me all the time. I also run a CAD community. I hope most of you had joined from that CAD community only. So you can reach me out there. So this was all about today's session, guys. I can see that we had already ahead of our time that we had scheduled. So let me know if you got any questions into the Q&A section. I will just stay here for more few minutes